This video is to accompany the engine sensor diagram that's placed on your assignment today. Take a look at the diagram. I'm going to go over some of the engine management functions real briefly to give you a better idea of what sensors do. On the left-hand side of the diagram are all the input sensors. An input sensor gives the ECM information. The ECM uses that information to control outputs. On the right side of the diagram, you can see the outputs. The goal here is for the ECM or PCM to run the engine at 14.7 to 1 stoichiometric ratio so the car passes emissions. That's the whole reason why we have computers on cars. Taking a look at the input sensors on the left-hand side, we start with the map sensor, throttle position sensor, coolant temperature sensor, exhaust gas oxygen sensor, crankshaft position sensor, camshaft position sensor, and a detonation sensor. You got an air conditioning sensor, you got a battery sensor, and there's a slew of other sensors on a car. Ambient light sensors, you have airbag sensors, ABS, wheel speed sensors. So this is just a small portion of sensors that can be found on a car today. In fact, oxygen sensor, some cars have 4 oxygen sensors or even more. So there are a lot more sensors than just what the picture is showing. Each sensor basically gives the computer information on how to make the car pass emissions. The throttle position sensor tells the computer the angle of the throttle. So as you step on the gas, okay, it starts at 0 volts, and when you step on the gas, it increases up to 5 volts. And anything in the middle is in between. Gives information on the throttle. You need that information to know how much fuel to deliver. The map sensor does 2 things. The map sensor gives barometric pressure sensor, which is atmospheric pressure. At sea level, it's about 14.7 psi. If you go into the mountains in Denver, it's going to be a little different. The car's got to know that because the density of the air changes. The map sensor is also a vacuum gauge. It's an engine's vacuum gauge, so the engine knows how much vacuum it's producing. The coolant temperature sensor is an NTC thermistor, negative temperature coefficient thermistor. That tells the PCM how hot the coolant is or how cold it is. Generally, it's around 200 degrees Fahrenheit at operating temperature. The exhaust gas oxygen sensor tells the computer how much oxygen is in the exhaust. The computer uses that information to change the air-fuel ratio. The crankshaft position sensor and the camshaft position sensor obviously tell positioning of those components. It's necessary to know the position of the crank and the cam to properly adjust timing. We know that our spark has to be delivered in the second stroke at the end of the intake stroke, usually about 10 degrees before top dead center at idle, more when you start giving it gas, but the computer needs to know when to deliver spark. So that's what it uses those sensors for timing. You have a detonation sensor. Detonation sensor senses, knock, okay? Engine noise. If your engine's making noise, the computer changes the timing to compensate for it so you don't damage the engine. A knock sensor, once you blow an engine up and it has a real noise, has to be replaced. Then you have an air conditioning sensor. The air conditioning sensor tells the computer when the AC is on. It uses that information because it knows it has to raise the idle. Once the AC comes on, it raises the idle. The battery sensor tells the state of the battery, so it knows how to control the charging system. Now, those are some of the basic sensors, some of the information that the PCM receives from those sensors. The PCM is a processing device. It's like a brain. It's not a very smart brain. It only does one thing. It processes engine information. Once it gets that information, it then controls idle through the idle air control valve. It controls the ignition by controlling dwell on the ignition coil. It controls any other solenoids, such as the EVAP solenoid, EGR solenoid. It controls fuel injection, which is the most important part. Depending on the input parameters from your sensors, it's going to change the length of time that your injector is on and off, which is called pulse width modulation, something you should have read about a couple days ago. Okay, so there you have it. There's some basics, very basic engine sensor information, and hopefully this helps you answer some of the questions preceding. Goodbye.